time?
It's 18 and 40 are the middle cup, and 28 and 44 are the top cup, which is cup 2. And don't forget the peak center.
28, 44 on top. That's cup 2.
Yeah.
And the peak center.
Yeah, and the peak center won't work for mass 40 because
like,
it's going to be too low.
The daily, what we are doing, like we do peak center, pass to the gas configuration. We do this argon background check and 18.
Okay.
That's before. That's how we did before.
Cool.
But we didn't do like for the other cup 28 or 44.
So yeah, like 40 and 28 are both checking air, right? So you're checking argon and you're checking nitrogen.
Okay.
Right. Argon, because it's such a small percent of air, will easily show you when there's a major leak.
Leak, yes.
Oh, but checking it on a different cup for nitrogen will also give you kind of the same information.
There's a table here telling what's the reading is good.
Yeah, yeah, it's somewhere in there. And it depends on the peripheral. So the amount of background you get from the conflow and GC will be different than the amount of background that you get from the gas pump. So maybe that would be another thing you'd write down. And maybe every quarter, I would just plot all that stuff on Excel and see if there's a trajectory or see if there's an anomaly. Because I had realized at some point that like everything was increasing slowly, but increasing over a few months. Okay. Like, oh, I guess there's a leak in my system. You know, like I never thought that thought never crossed my mind because it was happening so slowly that like argon one day was 18 millivolts, and then like 2 weeks later it might have been 20, and then 2 months later it was 24. But because it was happening so slowly, like I didn't get it until I plotted it. And whenever I plotted it, it was like, oh, we're leaking, but slowly.
Okay, that's correct suggestion.
Yeah.
Let's do that normal checking and also put on the Excel.
Yeah.
And then we can back up maybe.
Yeah, I had it back up, and then so like I do that every quarter, all the data, and then at the end of the year, I would like plot all of the year's data and just see. And you'll see seasonal changes probably too.
Oh,
so like.
I see people just plug in something they can do daily backup, right?
Really?
Chinese mostly.
Pen drive?
Okay. Yeah.
Like it automatically loads it up on the.
But this one has 2 hard drives. So this computer has parallel hard drive.
Okay.
So it's copy everything on the second one.
It automatically copies it on the second one.
Yeah.
That's nice.
I think so. But for sure we also make a copy. Maybe I need to buy a PC that we can put somewhere. We can copy or put data over there.
And the other utility of this is when you want to run. I mean, you may already run other people's data, other people's samples, and you could say like our long-term stability is less than 0.02 per mil. So like over the last 3 years, like our machine doesn't deviate. So when you send us stuff, you can be, rest assured, we have a really good sample.
Oh, super cool. Okay.
Yeah. So like no one sent us samples for 2 years because no one knows how stable the machine is because it hadn't been running. But after 3 years, okay, we can trust your machine now that you've been running long enough that it's stable. Because sometimes they're not. And I mean, why would you pay someone to run your samples if you can't trust the stability of the backgrounds
and also because we run the same standings.
Yeah.
The standing data for several years. Yes.
Yeah. The long-term stability of those standards. Yeah. Yeah. That's the way to do it.